yeah, let's not wait too long. I'm doing an introduction first, so maybe we can
Okay,
start.
yeah. Okay, then I will start, and I think we have like now we're live. We're also live on YouTube, so that's great. Welcome everybody to today's webinar, challenges in controlling your factory from the cloud. If I say it correctly,
Yeah,
if not, please correct me. Yeah, everybody, thank you so much for taking the time out and being here. You can post your questions in the chat. Ferry will answer them or immediately or finish his story a little bit first. Or if there are some other developers who can answer the questions, yeah, you can also do that by the chat. We will try to make it as interactive as possible. So yeah, first I would like to introduce you as well a little bit, Ferry. Since day one, since the first release of Microsoft Technologies, you were there. You were working with Microsoft Technologies, and yeah, now you're going to give us a very nice webinar about Azure IoT, I suppose.
yeah.
So yeah, I'm very excited, and I would like to thank you for taking your time as well. And I'm very excited, yeah, to hear about your story.
Yeah, thank you for the opportunity. I will start sharing my screen. Need 2 seconds to set it up. I have some slides. I try to stick with code as much as possible. I don't want to do a full session with slides because that's a little bit boring. So, and like we said, all us nerds shows the code. So, yeah, exciting to be here. A little bit about myself. Yeah, I consider myself a software nerd. I've done some other jobs, but every time I come back to software development. Like Roy already said, I've been working with .NET from almost from day one. Have seen all the technologies, web forms. Made a mistake for the first half year to work with VB.NET instead of C#. But made a switch really quickly because I saw that C# was the way to go. I've been working in OT, as we say, for 16 years now, and OT stands for Operational Technology instead of IT, which means I do factories from front to end. So everything from the instrumentation all the way up to the connection to SAP. My specialization is batch systems, and batch systems are recipe systems where, let's say you want to make a certain brand of shampoo, you select a recipe and the whole factory is being set up correctly, so the outcome of the product is the actual right shampoo. With that, those batch systems are connected to ERP systems from the ERP system and backwards, so that's what we do a lot. So I work at Conet. We have 2 offices, one in Zandam and one in Rotterdam. We always try to pick the nice offices, so a really industrial environment. Yeah, just to be in the environment where you work or you work for. And I have a new office. Yeah, notification. We are going to start an office in Warrington in the UK, so we're going abroad. I will actually be the business unit manager in the beginning, so I will set that branch office up. So what do we do as Conet? We have all these nice tiles. I'm not going through them one by one. The main tiles are the ones on the left, which is floor and plant automation. So that's the heart of a factory, where we control the full factory. So an operator can more or less control the whole factory with a keyboard and a mouse. So all the other parts are supporting branches or things we do. Analytics and measurements is instrumentation. Excellence in engineering is we write tools to generate full factories. Plant care is 24/7 support. And then, of course, at last, we have the process IT group, which is now a group of 6 people. 2 data scientists, 4 software developers, and they mainly concentrate on advanced process control with machine learning, but also on integration projects, so connecting PLCs, DCS systems to ERP or to other systems like laboratory information management systems. So what kind of challenges do we have in factories? And this is the introduction where I want to go through. Of course, cybersecurity, it's everywhere. But we have a different challenge than, let's say, the regular IT. I'm not saying that we are different, but we have some different challenges. Maybe you have seen these 4 or 3 items, which are the priorities for security officers. So if you have a normal IT application, you see that confidentiality is the most important. I'm not saying the other 2 are not important, but the most important. Keeping your data safe and where it should be is one of the things. The other thing, the next thing is integrity, and making sure that the data you store is still the data you want to have. And as last, we have availability. I think if you ask an IT manager, I think availability is on top, but that's what the ISO 27001 standard says. In process control or in factories, we have a different, we have it the other way around, and we have one more, and that's safety. It's really important that our applications are safe, because if someone hacks a system, you can actually damage people, because you can open a valve, and you can open a valve with 80 degrees or 100 degrees water, or even worse, open a steam valve. That's why we say safety is the most important. The next thing is availability, because safety and availability are something together. Integrity and confidentiality are important for us, but the least important. The other challenge we have in industries are being able to compare data. In the system I'm going to show you is a system that's now currently live in 7 or 8 locations all over the world. So you can see the challenges that we have a factory in America, which uses feet and meters per second, but then we have one here in Europe that uses meters. And how are you able to compare all the data without having to pre-process or post-process all those data? And last is the data visualization. That's part of comparing the data, of course. So how do we work with security? We have multiple zones. I think it's familiar for everybody. Of course, we have the internet or the cloud, which is where we want to end up everything. We always require a demilitarized zone with these applications. Then we have the actual factory floor, and one which we'd say that's where the IoT devices live. But we have one more layer, and that's the plant network, and that's where all our instrumentation, where the PLC lives. So the terminal network is where the SCADA system normally sits. So each of these zones can only communicate with the zone above. So the plant network can never communicate with the terminal network. The demilitarized zone can never communicate with the factory and internet. So all the connections should come from the actual system. So how do we do that then? What do we do? This is a normal setup as we deploy it for our customers. So we have from bottom to top in the factory network, we install a software data access, a middleware. Most of the cases, it's a package called Kepware. Kepware is really good at having a lot of drivers to different PLCs. In the factory, in the terminal network, we install a field gateway or an IoT edge device. And of course, then we break out into the internet, and then we have an IoT hub with time series insights or Power BI or whatever we need. So let me show you the field gateway. It's an older application. It's around 7 years ago when we started developing this. Microsoft just launched the IoT hub. We had great stories about how bad it could work. So it's not an IT edge, but it's still an application that's up and running. A lot of customers use it. So how does it work? Here we have the Kepware middleware, which is an application that's it's standardized on OPC. That's the part of this is a demo, or this is our QA environment. So it's all on one box instead of having three demilitarized zones. The middleware connects to the PLC, which is a time-based application. So here you can see that it's every 5 seconds that we, or every 100 milliseconds actually, that we read the data from a device, and we can actually see the devices, and we can see that in this case nothing is working because they're not connected. Then the application itself, it's a two-part application. We have a web front end, which is in the cloud. Users can log on to the system and can configure trials. This is this application, or the service of this application, is hosted in the demilitarized zone. How it works is that a user can configure a trial. What you normally do with IoT is you configure a sensor and then you let it run. You say, okay, I want to have the temperature of this room every minute. For this user or this customer, we did it differently. What they do is they create a trial. So they say, I want to do a SCOM test, and they select the user, category, and then they press next, and then they select the equipment or the IoT devices that they want to monitor. And in the end, you'll see all the sensors that are listed, and I press finish. And what happens then is that data starts flowing from the factory network, so the Kepware servers in here, that pulls the information from the PLCs or the devices, sends it into the demilitarized zone, or the demilitarized zone pulls it from the Kepware system, and then sends it into the cloud. So what have we done? We've built a manager for the users, because that's the difficult part in a factory, is that the factory's changes. In the past, the factory was something really static. The factory was built, and then 15 years later they did an overhaul, and then they built in new sensors, or they built in extra sensors. We had some changes during the years, but it was really minimal. What we see at the moment is that the factories changes more than there are Windows updates. So they add IoT sensors. They add a temperature sensor, vibration sensors, and they want to configure them themselves. So what they do is they can configure their equipment themselves, so they can click on it, and then they can add sensors which will communicate with the, so the sensor being detected automatically, and they can save it, and then they can configure the sensor. How much time do I want this sensor to end up in Power BI? And that's how they configure it. That's one of the challenges we had, is that the whole security branch was set up like this. Yeah, the next part was caching. This was we started out with caching on the edge. We had a Kepware server. From the demilitarized zone, we pulled the information into the edge device, and then we send it into the IoT hub. After a few days, we found out that the stream analytics behind the IoT hub sometimes crashed because it couldn't handle it anymore. It didn't have enough CPU power. And we lost about 2 hours of data because the IoT hub and stream analytics are set up like this, that if these stream analytics breaks, the IoT hub dumps all its data. So we built in a nice caching system on the edge, which worked great. It was just a standard SQL database. We wrote the information into the database, and when we lost connection, we stored the data, and when the connection came up, we reprocessed the caching database, and all the information was nicely stored in the cloud. But then we found out that factories, you would have think this is a large Fortune 500 company, that the networks would be great and awesome and there wouldn't be any issues. But we found out that the communication between the two zones, so between the terminal bus or the terminal network and the demilitarized zone, wasn't as stable as we would have thought. So we started thinking about adding a caching servers in the factory itself, and we started out with REST. So the user could go into the interface, and when he had a trial, and he did all, he had this button here that replaced the whole trial. What it does then is it pulls the information from this InfluxDB through REST, and then the InfluxDB would be sending the information back, and then the edge service would push it to the cloud again. We started out with REST. We thought, well, it's a simple service. Let's do it like that. We just asked the InfluxDB to send us all the data, but then security came in and saying, you can't be doing this. This is not allowed. We're closing the firewall. So sorry, but you can't communicate from the demilitarized zone back into the factory. So we came up with a new solution, which is, I think it's a great solution Google provides us now, is gRPC. The arrow is the wrong way around. So the Kepware server has now a small caching service, and I will show you the code in a few seconds. There's a live communication between the caching service and the service on the edge device. And now once the user presses the button, replay my trial, or even worse, when you forgot to start this trial, you can even start a trial in the past, and that does the same thing. So you can set a end date and then an end time from when till when he wants to have it, and you can do the same thing. So you can still say, oh, it was tank 10. I want to run this. I want to rerun tank 10 from that time till then, and the information being pulled from the system. So how did that work? So I have a question from Seth. Thank you for that. What security improvements does gRPC give over a REST API in this case? The biggest advantage of gRPC in this case is that we can start the session from within the factory to the actual servers. While with a REST API, which is a call you need to set up, or the other solution we could do is use something like long polling, where the service just checks every time. But now we have a live communication. So the service on the factory end starts the application. Hold on, let me shut down Teams. Thought I did. So that's the whole reason. Okay, thank you. So how does it work? The service has a, let me zoom in because this is unreadable, has a function which calls the read historic data. This is an endpoint. We have the data here, the protobuf with the actual request. So as soon as the client, which is a different project, 2-minute projects here, when it starts, it does a request. Well, let me show you the actual. Yes, this is the caching service. So what it does, it does get the cache, and it pulls it from the system with 100 items each to make sure that because one of the things we found is that one of these trials can hold up to well, up to 1,000, and even goes up to a couple of million items in the InfluxDB, especially if you have a longer running longer batch or trial, so over multiple days. You want to slow down the communication, because there still is a live communication between the two, because the normal trials are running, and if you want to rerun a trial, you want to limit the throttle the caching. So what we did is we built in a caching system that pulls the information every time from the system based on 100 items each. We did a lot of experimentation, and 100 seemed to be the sweet spot that the system wouldn't choke, and the normal data flow would still go, and that's 100 items per second. So it isn't that rerunning a trial takes multiple days. So that's the caching service. A little bit about OPC. That's the communication protocol from between the Kepware server and the edge device. So these two communicate with OPC UA, which is a international standard, and it actually stands for OLEDB for process control. So it is an old technology. We used to have OPC DA, which was COM based. Lucky enough, the OPC Foundation built something like OPC UA, which stands for Unified Access. And Unified Access is all based on the current day protocol. So it's all based on HTTPS and normal standard protocols. So what happens is the UA client creates a OPC server subscription, and it tells the subscription, give me all your information every 5 seconds, or every second, or every millisecond. And then it adds all the monitored items. So it tells the server which items it wants to have. And then the OPC server gives us an event when a item changes, and that's done every 5 seconds. This is really important on the next topic. That's why I'm explaining this. So the next thing our customer came with is, okay, now I have all this information in the cloud, but it's all based on different standards. You have your metric systems, and we have our imperial system, and how can we compare this data? And yeah, the different standards in the world, which means some work with PSI, some work with bar. So there's so many standards in the world. Even within in America, there's some plants that use PSI, and then you have pounds per no, the other one. So that was a problem for us, and we had to figure something out. So what we did is have a system. So we started out with manual conversions. So we had the servers always converting PSI to bar, and kilograms per hours, or pounds per hours, or liters per hours to kilograms per hours. But we found out that having to add all those unit conversions every time was a complete nightmare, because every time we thought we had all the unit conversions done, the customer came up with a new one. So what we've built is a scripting engine within the system. And let me show you one more. So we built a system that can do the conversions. Great. And then the customers came back saying, yeah, but now we want to know if we have an RPM, we want to know the tip speed, which is when you have a blade mixing a vessel. We want to know the tip speed of the blade. And we were like, okay, now we need to stop. We need to think about something smart. So we came up with a scripting engine, and we have some good thoughts about it. So how we're going to do this, what's usable for an end user, and Python was not new, but everybody was using Python. So we started out with C# scripting, but we found out customers don't understand C#. It's too difficult for a non-programmer to build a C# script to be able to work things out. And so we came up with a way of building scripts within C# and run Python scripts from a C# engine. Microsoft had released the scripting hosting, hosted scripting library, and that would work. So what we did is we gave the customers opportunities to build their own sensors. So all the unit conversions, we all stripped it out of the system, and we let the customer decide themselves. So what you can do is now give it a sensor a name, and this is the trigger tag, and that's why I explained the working of OPC. So what we have is, let's say, a turbine, which is just the standard mixers like you have at home, that has a RPM, but now he wants to calculate the tip speed. So what you can do is have standard Python. So I can import even OS, which will work, and I can say OS path, that works. standard Python to build its own scripts. So all the unit conversions, so we built templates. So if you want to convert from Fahrenheit to Celsius or Celsius to Fahrenheit, or have an n sample average, those are templates you can select, and then he can select the actual tag, so you can get the data from the system. So what happens now is, as soon as the OPC server gives us a updated on the turbine speed, this script will be triggered. So the refresh rate for this sensor is every 5 seconds. So every 5 seconds, this script will be triggered. So what we can do is now select that RPM. I'm just selecting one. Where is it? So RPM, and we can do our calculations. So this is a formula to calculate the tip speed from an RPM to meters per second. If the RPM is 0, of course, that's some validation. The user can do some tests. So you can say, oh, if the vessel is running at 50 RPM, he can press validate, and the system calculates it. And what was really important is the execution time, and we didn't have this before, this whole validation step. So the user came up with scripts that were so big and took like 6 to 7 seconds to calculate. And you can imagine if you have something that triggers every 5 seconds, that doesn't work, because every 5 seconds you get a new asynchronous call to calculate this whole script, and at some point the server would break down, because you basically create a memory leak. So we put it in this validation, so even if the user adds multiple sensors, you get multiple options, and they need to validate it before they can actually accept and add this sensor to the system. They can't activate it until this thing runs, and this is an average of 3, so it calculates 3 times, and the average is fine. And we'll put in an extra security in that the speed or the maximum execution time is 3 times lower than the actual refresh rate. So in this case, it needs to be done within 2 seconds. So how did it work? Too many. On the front end, it's really simple. We used it's more or less a diff editor, a diff with a package called ACE, and ACE is a JavaScript library that makes syntax coloring available for different or variant of languages. So we use ACE in mode Python. So now we have that nice interface where you can start typing Python code, and you get the nice syntax coloring. If you do an if statement, it's blue. If you have functions, it's I think it's red. Things like that. So that's really cool. And of course, we have this validate, which actually runs the script in the web interface. But of course, on the back end, we need to run everything in the servers. So what we did is we built a scripting service, which is based on the scripting hosting from Microsoft. So what it does is, as soon as a triggered, where is it? A triggered sensor is active. Oh, hold on, it's not here. So as soon as a triggered sensor, so every time a sensor, every 5 seconds, it hits that 5-second cycle, it starts. We get a message back from the OPC servers, which just calls a normal C# event. And then we go through it. We check if there is any sensors that need that calculation. If it needs a calculation, we start within the scripting service. We do the calculation, and we actually execute the script. And what we do then is we pre-process the script. So because the script normally is just a string, and what we do, no, we moved it into something else. What we do is replace the tag here with the actual value, and then we'll let it execute. And that works. So now the customers, the biggest advantage is that we don't have to build all the unit conversions or any conversions basically in the system. And the really cool thing is that even the customer came up with some really cool functions. Even at some point, we did some tests with even querying external sources, which worked. But we didn't allow for it because at some point you don't want to do external calls from a system because the script is fully injected into the server. So you want to protect yourself. We didn't limit the users. The only limit the user has is that they can only use the standard Python libraries. And we did add a function, which is really great that the guys from Microsoft gave us, that is that we can add some search path. So if we want to add pip modules, we can download them into a certain path, and then you can add the search path to the servers, and then it can still run those scripts, which was helpful because some users want to have some more advanced functions. The only limit we put on that is that you can't use the fancier PySpark, basically the C++ type libraries. So it's all pure native Python language, because in the scripting engine itself, Microsoft protects us from certain injections, and so it could be a potential security leak. And now this way, the user can't say, "Oh, just import these modules." We have the control over the modules that the end user can use. So if they want to have a certain module, they can ask us, and then we can upload it to the server. Okay, deployment, the last phase of this presentation. So what we did is, because back then the IoT Hub or the IoT Edge didn't exist yet, that's a technology that came later. Would have we done it differently now? Yeah, definitely. But it is what it is. At that point in time, 7 years ago, DevOps was even, or Azure DevOps didn't even fully exist. So after a few years, we moved from manual deployments to actual full release pipelines. So we have a full, like you've seen, we've been working on the QA system, we have a test system, then we have QA, and then we have production systems. So production systems are all part of the same release pipeline. So at some point when we do the QA release, we deploy the servers, and we have we're doing some scripting. So we release the pipeline. That's actually in the new release pipeline, is that we check the local time. So we make sure that all our deployments are, so we deploy on Tuesday, and the first deployment is in Shanghai. And then, so 6 o'clock in Shanghai, we get a message if it worked. There's even a rollback functionality in there. After that, we deploy in the Netherlands and UK, and then into America, because we want to do deployments basically on the same time, or roughly around the same time, same day, but you do have time differences. So what does our pipeline look like? We're stopping our servers if there are DB updates. So part of our build pipeline, the artifacts are the actual servers, the web interface, and the migration script, the SQL migration script. So what it does here is checks if the DB doesn't exist, it creates it. So it's all the old SQL option from the release pipeline. If necessary, it adds a DB. It all works with variables and of course Key Vault, and then it runs the database migration. So more or less, it only fires up a SQL script. Yeah, one thing we noticed is that because our application is a longer running application, to communicate between the two services, we had to use a tool called Hangfire. And Hangfire sometimes has the nasty habit of leaving the application pool stuck, even when you stop it, because you have the option to stop the application pool from the deploy site. it still didn't work, so we had to do a simple function to make sure that everything is being reset before we do deploy the app. We had a lot of failures on our release pipeline, and this was the quickest fix. Actually, 2 years later, Hangfire came up with an update, and we didn't use it. We didn't need it anymore, but we left it in because better safe than sorry. And this is a IES reset. It runs in a couple of seconds actually. So we have a standard app deploy. And then we deploy our servers. In this case, this is our a Trumbull site in America, which has the application running locally, full application running locally. We're moving more and more sites to a central web application, so they run everything from the cloud. So that's how we deploy our applications onto each site. So I don't see any questions yet. Yeah, that's about it. That's my full presentation on the challenge we had in our IoT journey. So Ronald asked a question. It looks impressive. I suspect these various environments are 24/7 without downtime. Is the availability not very dependent on Microsoft update cycles and unexpected urgent updates? Yes, that's our biggest challenge. That's one of the reasons why this application will move into IoT Edge solutions, because what we can do then, instead of having one here, having two. So we have full availability. The package I'd shown, Kepware, already has an option to run twice. So in the future we will use this, and what we do now is this customer is really strict, so they have a cycle of every 4 weeks we need to deploy all security updates. So yeah, the system goes down. That's what it does. And what we now have, because we have the local caching and the caching on the edge, what we first do is we update locally. That's where we do break. We do have a data cap at the moment. That's just because we don't have a second Kepware server at the moment. In the future we will have that, but for now we don't. Lucky enough, the factory is a fully isolated environment, so we can get away with stretching the patch cycle to once every 6 weeks, or even every 2 months. So, and factories do go down. Well, at least these factories do have downtime or plant maintenance every 2 months. So we try to work it out with them to have the minimum data cap that we can have. And we don't have any problem on the edge in the demilitarized zone. I think they even run the updates bi-weekly. Because there also is on the systems in the demilitarized zone, there's a vulnerability scanner from Quellsys, I guess. So that checks the server every week. Sometimes the Quellsys scan is so aggressive that the servers go down for a couple of seconds because it restarts itself. But the vulnerability scanners can be quite aggressive and take down your server. But then again, we have the local caching and we have the InfluxDB where we can rely on. This year we had a major overhaul on the Azure side of the application, which was great because we had the influx and the local caching. So they did their upgrades, they moved their servers to a different location, and they switched on the servers, and our servers came up and they just pushed all the data and everybody was happy. Do you update your Hangfire servers automatically with a pipeline? If so, how do you preserve running jobs? So yes, we had the same problem. We are lucky that we only use Hangfire for commands from the. Actually, we're abusing Hangfire. So what we do is the customer on this end creates a trial, and that will result in a fire and forget job for the service. And then the service picks it up and then starts the job. So what we do at the moment is we tell the customers to not to do, or we actually shut down the web application at that point. So the customer can't do changes on the system. We inform them, of course. So we don't have the problem with running jobs. And all our jobs are, because it's only commands, it's only a couple of milliseconds. So it's not every job doesn't, it has we don't use Hangfire for long lasting jobs. Everything in here, because it's IoT, every function has been profiled, so it needs to be running. It needs to be done in matter of milliseconds, because you can imagine that this system, one of the sites produces 24 million messages during a weekday. So you can imagine that we had to profile the whole system and to be as optimal as it can. So in the beginning, we actually did start with Hangfire to send the message to the cloud, but we took it out because it was too much overhead. But I can imagine you have the problem with running jobs. Solution with that, of course, is use the Hangfire Enterprise version, because that has an option to preserve your jobs and load balance them over different servers. But still, if you shut down a service that has a running job, you'll still lose it. But there's a good functionality in Hangfire with that you can see how many jobs are being processed, and you can always set your worker to 0, and then you shut down the server. So I would handle this in my server shutdown. Actually, the application is still working with because it's still .NET 4.6, I think, from the top of my head. We're still using Top Shelf to actually handle the service, starting and stopping of the service. And what you could do is handle your jobs in your shutdown of your service. I would never shut down services if there's still a job up and running, and you should handle it in your job itself if you want to be able to stop long running jobs. So I don't think there are many more questions.
Then I'll join in. Thank you so much, Ferry. I think it was very clear.
Oh, there's one more question. One second.
Wrong. Yeah, please pose him.
Yeah, no problem. Yeah, we're here till at least 3 o'clock. So
yeah, we still have some time, so no worries.
Yeah. So the question is, I'm using Python 3 myself, but sometimes I was disappointed about its performance speed. Unfortunately, I'm not suffering from memory leaks. I fully agree with you. I'm working on a different project at the moment with Azure Functions, and our first, because I'm on a team with two C# developers and 4 data scientists or data engineers. So they love Python. I can imagine that Python works. It's really quick to build something simple, and it works. But if you come to performance, so what it did is they had a longer running service to process data from a factory, actually. So they pull the information from a SCADA system and they handle it in Azure Synopsys, and they're using Python. And I did a test, and if I use so they're using PyArrow to handle head-up files, and it would took 200 milliseconds to run the full function, just to open the file, convert it to JSON, and send it out to an event hub. And I changed that now. I did some tests with C#, and we're going to deploy this next week. We did some tests with C#, and it runs within 20 milliseconds. So yes, definitely. But I think I don't know if you follow Guido, the Dutch guy who invented or created Python a long time ago. He's now working with Microsoft, and they're actually looking at Python 4 to actually be being up and see you responding. Yeah, they want to make Python precompiled or even compilable. It is indeed a 5-year long project. I don't know if it ever comes up, and I know if you know the history about Python, but Python 2 and 3, there were a lot of breaking change, and I think that disappointed a lot of people. So I think that the project will split up. Personally, I wouldn't use Python for these type of applications. I think it's nice when you do data engineering one-offs, but personally, I'm more restricted to Java or .NET or even C++. I know that a lot of people disagree, and I understand that. I think a project like Django is really great, and I think it works. But if you do business applications like I do, where you have to build it really quickly, as flexible as possible, but also needs to be running for 10 years without even shutting it down. I would still go to the .NET framework, especially nowadays where they have integration with Linux and you can run it basically everywhere. The .NET Core team is really smart guys over there, and I think that what they're building is more and more, it's greater. I do see a lot of changes in the C# language where it's becoming complexer, but now you see a group standing up, which makes C# more a functional language. So yeah, I think we have a lot of interesting times to in the next couple of years to see where the .NET environment and C# is going ahead.
Okay, thank you so much, Ferry. Are there more questions? And thank you so much for all your input, Ronald, and also Seth for your very interesting questions. I think. Please, if you still have any questions, raise your hand right now. Or if everything is clear, then we will close it. Everything, you can look everything back as well on our YouTube channel. We're live on YouTube at this moment. And yeah, so you can find it there. We're recording the whole webinar, so you can look it back as well. Yeah, then if there's no more questions left, then I would like to thank you so much, Ferry, for all your input.
Yeah, thank you for the opportunity.
I would like to ask the people who are here to check the link in the chat as well. To improve our future webinars, we have like a questionnaire form. It takes 2 minutes, but it's just to improve for our future webinars and meetups. And of course, I'd like to thank you all for your time, for being here. So the link in the questionnaire is here in the chat. And yeah, thank you so much for your time, and hope to see you next time at one of our next webinars. Thank you so much.
Yeah, thank you all. Take care.